Okay. Now we are going to start with a new lesson. Heat. So now in winter we use hot water for bathing and washing our hands and legs, and cold water during summer season. We wear woolen clothes during winters. In summer, we prefer to wear light colored cotton clothes. Why? Because cottons give us a feeling of coolness, or cotton clothes in summer keeps us cool because it allows air to pass through our clothes. Okay, it allows air. Cotton clothes allow air to pass through, keeping us cool. When we rub our hands together, when we rub our hands together, they become warm. Similarly, an object becomes hot when a hammer strikes on it. But how do we know whether an object is hot or cold? Or how do we find out how hot or cold an object is? And what kind of substances produce heat on combustion? So, in this chapter, we are going to talk mostly about that. Okay, what is heat, how it is produced, how it travels, how it like burns. Okay, how its effect is there in burning. Okay, so we are going to talk about that now. Heat and temperature. We experience cold and heat every day. Right. Having less or more heat causes us to feel cold or warm. Okay. If the temperature is more, we'll feel hotter. Okay. If the temperature is less, if the heat is less, we'll feel colder. Now, when heat flows out of our body, we feel cold. And if the heat flows into our body from the outer environment, we feel warm or hot. Okay. Now, heat is a type of energy which is related to the motion of the molecules of a substance. Okay? Heat is, we know that heat is a form of energy, right? Can I have your videos on, please? Both of you? Turn on your videos. Now, heat is a type of energy, okay, which is related to the motion of the molecules of a substance. It relates to the motion of the molecules of a substance. We know that every substance has molecules, right? Be it solid, liquid, or gas. Solid molecules very closely packed together. Liquid molecules they are loosely packed, whereas the gas molecules are very loosely packed. So it is related to those molecules of a substance. Now, a physical quantity which determines the direction of flow of heat is called its temperature. Okay, it's is called its temperature. Means that um, what determines the flow of heat? We know, like there is this thing that heat flows inside a substance. Okay, heat flows or moves inside a substance. What is the direction of that flow of heat? Okay, that is determined by temperature. Okay, higher the temperature, see, look at this very carefully. Higher the temperature of the substance, faster is the movement of its molecules. Thus, more energy exists in the form of heat. And heat always flows from a body at a high temperature to a body at a low temperature. Therefore, during the summer, when the temperature of the environment is more than our body, we feel hot. And in winter, the temperature outside is less than temperature of the body, hence we feel cold. See, now take a look at this. Temperature I was talking about. Okay, we are talking about temperature. Now, what happens is that if like the temperature is more, you will feel that something will heat up more quickly. Okay, faster, and the heat will move on in its body faster. Okay, like take a look at this rod. Okay, I have this iron rod. Okay, and here I've put it on a flame on this side. Okay, here I've put it on a flame on this side. So it will start getting heated up from here. Okay, look at the red portion. It will start getting heated up from here, and then the heat is going to travel here slowly. Okay, and then it's gonna heat up the whole rod, right? It's gonna heat up the whole rod. Okay, if this heat is at a very high temperature, it will heat faster. The rod will heat up faster, the entire thing. Why? Is because this movement of heat is like more. Okay, faster movement, faster movement of heat is there. Okay, more temperature is there, faster movement of heat is there, and more energy exists in the form of heat. Also, more energy will exist in the form of heats. Okay, if I reduce the flame, if I reduce this flame, okay, what happens now? That I will reduce the flame. Okay, I reduce the flame. So what happened now is this movement of heat will become slow, and the rod will uh, heat up slower. Okay, the rod will heat up slower. Why? Is because the temperature I have slowed down. So because the temperature is slowed down, the movement of heat in the substance or in the matter in the body of something will also decrease. Okay, will also decrease. Also, it will produce now less energy, lesser energy. Okay, lesser energy. Hello, Abraham. Good morning.
Hello, ma'am. Good morning.
Good morning. Okay. So if the temperature is more, the heat will the heat will travel faster. Okay, the movement of heat will be faster in the molecules, and it will produce more energy. And if it is less, then the molecules like the movement of heat in the molecules will be lower, and it will produce less energy. Also, what is this concept? That heat always flows from a body at high temperature to a body of low temperature. Okay, body of high temperature from high temperature to low temperature. You have to remember this. Okay, low temperature means from high temperature, something that's very hot. From there, it will move to something that has a lower temperature. That has a lower temperature. That the example that they give us is that in summer, okay, in summertime, we have this is the outside temperature. This is us. Okay, so in summers, the temperature that is outside is more, okay, more compared to our body temperature, compared to our body temperature. That is why we feel um that is why we feel hot. Okay, that is why we feel hot, because the outer temperature in the environment is higher than our body temperature. Okay, but what happens in winter? What happens in winter is that this outside temperature becomes less, okay, and the body temperature becomes more compared to the environment, okay, compared to the environment. That is why we feel cold, okay, that is why we feel cold, because the heat travels from high temperature to low temperature. The heat always travels from high temperature to low temperature. Okay, now, okay, understood all of you? Okay, we will move forward. Now, heat is a form of energy which is associated with the motion of the molecules of a substance. You might have seen that when water is boiled in a kettle covered with a lid, then its lid moves up frequently due to the pressure of steam. Obviously, steam is formed due to the heat which raises the lid up. Our clothes dry up in the sun due to heat. We obtain salt from seawater with the help of heat. Heat, as it has the capacity of doing work, is a form of energy. Okay, we just studied the heat is a form of energy. Why? Because it has the capacity of doing work. Okay, these are the examples where heat does something. Okay, the heat energy does something like um, raising the lid of a kettle. Okay, then we have drying up of our clothes and obtaining salt from the sea. Okay, if you observe your surroundings carefully, you will find that many other types of energy are transformed into heat. Okay, so there are also a lot of other types of energy that transform into heat. What is this? Is if you if you take a look at burning of a candle, we know that burning of a candle is like chemical energy. Right, it is a chemical energy and it changes to heat. Why? Because heat is like produced when we burn a candle. Similarly, when electric energy, when a furnace is like turned on, that works on an electric energy, but the electric furnace gets heated up. Okay, because of electricity, it heats up and the electric energy is converted to heat because heat is produced in it. Okay, in electric heater also it heats up because of electricity, but it produces what? Heat. Okay, it heats up, like it works because of electricity. What it is producing heat. Okay, so all of these energies, electric energy and chemical energy, they all get converted to heat because they are producing heat. Okay, understood? Any doubt till now? Okay. Now, effects of heat. The higher the speed of the molecules of a substance, the higher its temperature. And by providing heat, the speed of the molecules increase. When any object is heated, one or more of the following effects may appear. Okay, so I explained that the higher the speed of molecules, the higher its temperature. Okay, or like the more heat we provide to something, okay, the more heat we provide to something, the more its molecules, the like speed of molecules will increase. Like I gave you the example. If like I'm cooking something on a gas. Okay, I'm cooking something on a gas, okay, in a vessel, in a container. Okay, if I like put the flame to the highest, if I cook it on a high flame, if I cook it on a high flame, the vessel will get heated faster. Okay, very fast it will get heated, right? And if I cook it on lesser flame, then it will heat up slowly as compared to the high flame, right? Why is that? Why that happens? Because when the temperature is high, the molecules will it will increase the heat, the traveling of heat in the molecules. It will increase that speed of molecules. Okay, like when the heat is traveling in the vessel, okay, in the molecules of the vessel, their speed will increase. When you like heat it up on a slow, like less fire, so slowly the heat will move, and only slowly it will heat up. Okay, so this is how it affects, like this is how the change of temperature affects the speed of the molecules of a substance. When any object is heated, then there are some changes that appear. There are some changes that appear when an object is heated. What are those changes? Change in size. Now, when we heat metals like iron, mercury, and like other metals, what happens is they expand on heating. They expand on heating. Now, there is also another change, that is rise in temperature. When a body is heated, it becomes hot. If we heat any vessel, an iron rod, something, it will become hot. Another change is the change of state. Some materials, they change their state when they are heated. Okay, if I like heat up ice, it will become water, and then if we keep heating up, it will become steam or gas. If I heat plastic, it will melt. Okay, from solid it will change to liquid state. Okay, the plastics that can be melted, those plastics. Okay, thermoplastics. Then so water in liquid state changes to solid, and liquid changes to gaseous state. Okay, so this happens. Change of state also happens on heating. Okay, then some things they become like they like some things they evaporate, okay, like liquids when they are heated up. Some solids they become liquids when they are heated up. So that is a change in this state. Okay, three states. What are the three states of a matter? Solid, liquid, and gas. On heating, this changes. Then there is change in physical and chemical properties of a substance. Iron, when heated, becomes red hot. Okay, there is also physical changes in the physical properties, shape, size. Okay, chemical properties means the nature of the substance. Okay, when it is heated up, that also changes. Okay, shape, size changes. Okay, state changes, nature of the substance changes. Okay, and chemical properties of a substance changes. Then there is this is like about the living things, damage to living cells. Okay, this is also an effect of heat. If the leaf is lying in the sun, then it becomes dry. If the person remains in the sun for a long time, then the color becomes black because your body produces melamine. Okay, um, so that is like our skin cells. They become darker in color. Okay, our skin cells they become darker in color, and also further like in prolonged times when we like go out in the sun for a long period of time and like heat and heat waves and all might cause sunburn and things like that. Okay, so that is the damage to living cells caused by heat from the sun. Any doubt in effects of heat?
Yes, ma'am.
Yes, Anna.
Um, you said that if you increase the temperature, then the thing you're like boiling or heating up on high temperature, the molecules will speed up.
Yes.
So when it comes to if we're heating a vessel
Mm-hmm.
and we're heating it at a very high temperature, do the
Mm-hmm.
molecules get a little bit separated or they'll still be rigid and like close in like are they
They
still packed?
they are still closely connected. Okay, molecules are still closely connected we are talking about solid, but the thing is that their movement increases. Okay, the movement
Okay,
increases, the movement of heat that is going in the molecule in the like molecules of the vessel, that movement increases. Okay,
okay, ma'am.
yes. Now any other doubt? No. Okay. Then there comes a measurement of temperature. The measurement of hotness or coolness of a body is known as its temperature. How cold a body is or how hot something is, that is the temperature. Okay. Generally, we use our sense of touch to decide whether an object is hot or cold. Usually, we touch something and we can tell that if something is cold or like hot. Okay. So, like when we get fever, when we touch ourselves, or when our mother touch our forehead and check if we got a fever, okay, she can tell by touching our forehead, okay, our cheek that the temperature is high. But can she tell exactly how much temperature are you having, or what degree fever you are having? No, you cannot just tell by touching that this degree temperature is there. Okay, you can just classify that it's very hot, okay, or very high temperature, or medium it's there. Okay, only some, you're getting only some temperature like slight fever. Okay, but not exactly. We cannot just say exactly what degree by touching it only. Okay, so what to do in that is there is a device called the thermometer, which is used to measure the temperature. Okay, two types of thermometers are there. One is to measure body temperature, okay, of us, and other is to measure the temperature of chemicals and various other substances. Okay, so now let's give this a read. The fingers of right hand feel hot and fingers of left hand feel cold. The fingers of left hand feel hot due to colder than lukewarm water. Okay, this is the activity. This is the activity where you have put one hand in ice cold water and one hand in hot water, and both the hands in lukewarm water. Lukewarm is not very cold, not very hot, like mild hot, warm water. Okay, that is lukewarm. So what happening is, after like you have kept your hands, the fingers of the right hand feel hot and the left hand feel cold. Fingers of the left hand feel hot due to colder than lukewarm water. Okay. So because left hand was kept in the cold water, okay, right was kept in hot water. You put it in lukewarm water, the hand that was there in the cold water, the fingers will still feel colder. Okay, so it is clear that we can use our sense of touch to decide whether an object is hot or cold. But to find out how hot or cold an object really is, we use a special device known as a thermometer. First one is clinical thermometer. Clinical thermometer is the one that we use to measure our body temperature. Okay, it's used to measure our body temperature. The another one is called laboratory thermometer, which is used in labs to measure the chemicals. Okay, to measure the temperature of chemicals and chemical substances. Now, the thermometer that measures our body temperature is called a clinical thermometer. Hold the clinical thermometer and observe it in your hand. Observe it carefully. You have thermometers at your home. Are you all having? Yes.
Yes, ma'am.
Okay. After class today, I want you to go and observe it. Okay. Go and observe it. Anna and Emma, are you all having?
Yes, ma'am, but I have an electric thermometer.
You have an electric thermometer. Okay. Yes.
I have both of the types of thermometers.
How many types of thermometers?
Two, the electric one and the one with the I forgot what it's called.
Okay, the normal one and the electric one. Hmm. Okay, right. We are having an electric one too, electric thermometer. There is like the traditional one that was there. Okay, the electric one where you get the switch to power it on, to turn it on and all. So like you can observe them. Okay, you can check out the scale that is there on the temperature on the thermometer. Yes, Abraham.
Ma'am, I don't exactly have an electric one, ma'am. It's like a thermometer. You have to
Hmm.
press the button, like on the thermometer, you have to press a button for it to come on, and then you put the thermometer inside the person's body, like
Hmm.
inside the person's armpit or in the person's mouth. Then after some time, it will beep when the temperature reading is done and tell you the
Mhm.
reading.
Yeah, that's the same thing I also have, ma'am.
Yes, that is an
Ma'am, that's
electric.
the same thing. That's the electric
Same
one.
thing. Me too. So that is like an electric thermometer because it has like a button and it works on power, right? Maybe like small battery cells. Okay, so that is there. But previously there was like a more traditional thermometer that was used, not battery operated, like this. Okay, like this is a traditional one. Then hold the clinical
I've
thermometer.
seen a thermometer which has a long glass tube.
Long glass tube. Yes, that is a laboratory thermometer. Okay, that is a laboratory thermometer. Not like if you see like the very long one, very long glass tube one, that is laboratory. But usually these traditional ones also were in like glass thermometers.
Ma'am, and when I saw them, my mother said not to touch them is because they were pure glass.
Mm-hmm. Yeah. Yes, they are pure glass. And like laboratory thermometers are very long tube. Okay.
Ma'am, you have to be, no, ma'am, so the person
They
can
have,
take the thermometer out. Or...
yes, they have to be. That's right.
Ma'am, you
Now,
cannot use a digital thermometer in the laboratory.
can we use a digital thermometer in the laboratory? I don't think so. Okay, because like laboratory thermometers are differently designed than the ones used in our body, used like to test our body temperature. Right. The laboratory thermometers are like specifically designed to measure that much high temperatures that the chemicals can go to. That's much more than our body temperature. Okay. So they are specifically designed for that purpose. You can like check it out if like there are electric laboratory thermometers coming. I've seen a traditional one, a traditional laboratory thermometer. I've seen a long glass tube is there, which is used to measure very high temperatures, very high. Okay, so check like if they have like electric laboratory thermometers. Okay, okay. Now you will find that a clinical thermometer consists of a long, narrow, uniform glass tube. It has a bulb at one end. This bulb contains mercury. Outside the bulb, a small shining thread of mercury can be seen. You can see a kink near the bulb. This kink prevents mercury levels from falling on its own when the thermometer is taken out of mouth, and we can read the thermometer easily. You will also find a scale on the thermometer. This is a scale. This thing is a scale. The scale we use is the Celsius scale, indicated by degree C. Okay, degree C is degree Celsius, degree F is degree Fahrenheit. A clinical thermometer reads temperature from 35 degrees Celsius to 42 degrees Celsius only. Okay, so this is our like our body temperature. This is the max out. Okay, so that is like in degrees Celsius, 35 degrees Celsius to 42 degrees Celsius. If we convert it to degree Fahrenheit, it is 94 degree Fahrenheit to 108 degree Fahrenheit. If you've like heard somebody say, oh, they had a like 104-degree fever, 108-degree fever, ever heard like that? Ever heard
Yes, ma'am.
somebody? Yes. Oh, they had a like 108-degree fever, 104-degree fever. So they say it in like if they're saying like 104, 108, then they're measuring it in degree Fahrenheit. Okay, usually it's like written in degree Fahrenheit, the temperature. Okay, whereas Celsius, the scale is there in Celsius, but usually they like convert it to degree F, and then it's like said.
Ma'am,
Okay. Yes, Abraham.
ma'am, you do have electric laboratory thermometer. And
They
just
do have.
like the picture I sent in the chat.
Okay, they do have electric laboratory thermometers. Right. Yes. Hmm. Okay. Yes. Yes, Abraham. That's right. Hmm. Okay. So, in a thermometer, another scale is also used to measure temperature, which is known as Fahrenheit scale. In Fahrenheit scale, thermometer reads from 94 degree Fahrenheit to 108 degree Fahrenheit only. Okay, so we are, but it has also given you the healthy temperature range is 37 degrees Celsius or 98.6 degree Fahrenheit. Okay, like 100 degrees also fever, 102 is fever, 104 is fever, 108 is fever. These are all like I've like the fever measures that I've heard. Okay, even like when you get 100, it means a fever. Okay, it indicates a fever, like not very high, but still it like indicates a fever. Like if it goes from like 10248, like very high fever. Okay, so we will stop here for today, and tomorrow we will continue from reading a clinical thermometer. Okay, 5 minutes break is there till 8:20. Okay, 20, we're gonna begin with math. Hello, Jeshua, good morning.
Good morning.
Good
Hi,
morning.
ma'am. Good morning.
Hello. Okay, let's begin. Please turn on your videos. Okay. Abraham, are you there?
Yes, ma'am.
And Emma?
Yes, ma'am.
Okay. Okay, so Abraham, your screen is black for me. And Emma, can you turn on your video?
Yes, ma'am. 1 second.
Yes. So, Abraham, you asked your doubts in the grouping method, column method, and distributive property or like distributive law. So, I'm gonna take that first right now. Okay. All the three things. I'm gonna like re-explain them to you. Okay. This is the column and the grouping and the distributive is from the fifth chapter that we did when we did the algebra. Okay, so first up the grouping method. Okay, first who's gonna tell me what are like terms and unlike terms?
Unlike terms are numbers which have the common x common or a common algebraic expression.
Yes, good. So like terms are those terms which have common variables, which have the same variables. Okay, basically which are the same variables like 3x and 7x. Okay, then like then you can say 3a 8a. Okay, those are all like a is coming, so they are like terms. If x is coming into terms, and those are like terms. Unlike would be 8a, okay, and 12x, like one x is coming, another a is coming, those will be unlike. Grouping method is based on combining the like terms, okay. We take the like numbers with same variables, put them together. We take the number together and put them together. See, um, if you take a look at 7 is a number, only number, not a variable, doesn't have a variable, not a term, only a single number. And 3 is also a single number, right? Then if you take a look at 14x and 5x, both x is coming in both like terms. Then we have a, only poor alone a, okay, no companion. So we are going to take that in the end, okay. Only a is there, so at the end. Now we will put them together. We're gonna put them together. How? In one bracket take 7. Okay, now also the question says that you have to add 7 minus 14x and 5x minus a minus 3. Okay, so 7, and this minus 3 you are going to put with 7. Okay, so bring this minus 3 here. 7 minus 3. Very important to remember, signs will not change. Okay, signs will not change. Minus 3 is there, you just put minus 3.
I have a question about this.
Yes.
We are performing this grouping method, ma'am. I have
Mm-hmm.
my doubt was that, like, when we are rearranging, will the will the sign of the sign ahead of the number will move, right, with the number when you move the number?
Yes. When you are grouping, the sign ahead of the number will move as it is. When you're solving, that time signs are gonna change. When you're solving it. Okay, right now we are just putting them together. So the signs will come as it is. But when we will solve them, that time the sign's gonna change if needed. Okay. Okay. Now take a look at this. 7 minus 3. Okay. Plus, because I'm adding. Okay. Plus minus 14. Minus 14 x, okay, plus 5x, because 5x is in addition, and minus 14x is in minus, so minus 14x plus 5x. Then our poor alone a, okay, which is only alone, no companion, so put it at the end. Everything that has no companion, put it to the end, at the end.
Why did you not put plus a?
Plus a, no, minus a, because a is in minus. Take a look here. A is in minus.
Ma'am,
So we
why
take
did
the
you put a plus in the middle?
why will we not put a plus in the middle
So why do
is
we put a plus in the middle of -7 and -14?
minus 7
-7
minus 7 and minus 14. See, this is like when we are grouping, then this became a complete term. Okay, and because we are doing addition, we're going to put a plus and then we are going to put the second term. Okay, but a, we will not make it like plus minus a. Okay, plus minus a. Okay, like you can just put a minus a, and if you do that plus minus a, it's going to ultimately become a plus minus and minus, so minus a. Okay,
But ma'am, the same thing happens, no? Plus minus 14x.
plus minus 14x. See, this plus minus 14x, you're gonna like first evaluate the inside. Okay, first you're gonna evaluate the minus 14x plus 5x. Once all the inside of it. Okay, and then we are like gonna put the sign. So gonna do 7 minus 3 4 plus, first I'll solve the inside, minus plus minus, we're going to do 14 minus 5, 14x minus 5x. We have minus 9x minus a. Now you will evaluate these signs. In this step, you're going to evaluate these signs for minus 9x minus a. Okay. Now, see, the first thing is grouping of like terms. Okay, grouping of like terms, and we solve the like terms. Grouping and solving them. Here we solve, okay, and change signs or evaluate signs. And then we'll get the answer. Okay. Now, any doubt, Abraham?
Ma'am, can you give us a question to solve? Then I understood.
You understood. Okay. Yes, I can give you a question to solve. Do you want me to first show you the column method also, and then I'll give you a question to solve?
Can I solve the grouping method first, ma'am, and then
Okay. Try this question then. Try this question. 7 minus 14x plus oh sorry, I just did this with you. I'll like give you a different question.
ma'am, I didn't. Can you just repeat what you said?
What I just said is that I'm like gonna give you a different question for a plus 3b minus 12c plus b plus 2c plus 6a minus c. Try to solve it by grouping method. Put all the AA's together in one bracket, then put all the BB's together in one bracket, then put the CC like variables terms in one bracket. And don't change the signs. Put them as it is. Just put plus in between when you're done with AA things, put plus. When you're done with then put the BB things, then put a plus, then you do the C things.
No.
Then Abraham, what are you getting?
Ma'am, is it 10A plus 4B minus 11C?
Yes, Abraham. Good. That's the correct answer.
Okay, ma'am. And ma'am, I kind of understood the column method more or less, ma'am. Ma'am, but can you explain the diversion property?
Distributive property. Yes. Do you like to understand? Yes. I'll explain the distributive and also I'll just quickly go over the column too. Okay. For like a revision for all of you, I'm gonna solve this question first. See, I have A's, B's, and C's. First, let's take the A's, 4A plus what's my another A? 6A. So 6A. With an addition, open another bracket. Then I have my B's, 3B and B plus B. Then I have my C's. Then I have my C's. What are my C's? Minus 12C plus 2C minus C. Okay, those are my C's. Add the A's, 4A plus 6A, 10A plus 3B plus B, 4B. Okay, plus, okay, now take a look at this. This is signs. Take a look at the signs. Plus minus is there. Okay, then minus plus is there. Okay, so first what we can do is, if like I told you to do the inside thing first, I told you to do the inside thing first. So minus plus minus. Okay, minus plus minus. Minus 12C plus 2C minus 10C. Then we have minus C. Minus minus is plus. So minus plus, minus minus plus. So 11C. Okay. And now take a look at these signs. Minus, plus minus, minus. So we put a minus here and we write what? We write minus 11C. This is my answer. This is my answer. Joshua, are you getting?
Sort of, ma'am.
Sort of. Okay. It's okay. Like, since this is like an old concept, okay, no problem if you just get it a little bit right now. It's okay. Okay. So, we have like 10A plus 4B minus 11C. How we got that? We got that by grouping the AA things, BB things, CC things, and then adding them up. Okay, that's all we did. Now quickly take a look at column method. I'm gonna do the first question with column method and show you all real quick. In column method, also we add, okay, but we add them in a column form by arranging them. What were my digits?
I just have one question, ma'am. There's no subtraction, right?
Subtraction is also there, Abraham. But same method is followed in subtraction. Same thing we follow in subtraction. Just that here when we are putting addition sign, look, here when we are putting addition sign in subtraction, we put minus sign. Okay, that's the like only difference. If you want, like after today's class, you can go and try out some subtraction questions. Okay, if doubt comes, you can ask me. Okay, now I had 7 minus 14x, and my other term also was there, 5x minus 9 minus 3. Okay, I had 7 minus 14x and 5x minus a minus 3. What I will do is, my 3 and 7 are companions. Why? Is because they are only numbers. So bring this minus 3 here. Bring this minus 3 here. Okay. Then I have 5x. That is in plus. So put plus 5x. Then I have the lonely a. Put minus a. Okay. Okay, at the end. Arranged it in column. I arranged it in column right below one another. Number together, x together, and then A was like only A, so put it at the end. That is the arrangement you do in column method. Now we will solve it. You can put the addition sign here, put this whole thing in bracket, and put a plus here. Okay. Now minus A as it is, no companion.
Ma'am,
Okay.
you just show me again how you arranged it.
How I arranged it? Okay. Yes. So I had 7 minus 14x. You can write the first term as it is. Okay. 7 minus 14x. Then in the second term that I had, what I did is I saw like 7 is my number and it is coming first. 7 is my only number, it's coming first. So I put 3, which is also my only number. Take the 3 below 7. Like only number together, one above and below each other, like 7. Okay. Then I moved on to like 14x was up. Then I had a similar term, like term was 5x. So right below 14x, I put 5x. But I did not change the sign. 14x was in minus, so minus 14x, and 5x was in plus, so plus 5x. Okay, no changing of signs. Then I moved on to A. Now A was only single term, so I put it in the end here. Okay, I just put it in the end. And here I put a bracket and addition sign because we are adding. And here we can also like evaluate with the like addition sign, like just like here, how addition signs are there. Okay, here I've put an addition sign. Okay, always we start. Yes, Abraham.
Okay, ma'am. If it was addition, we would do what? Ma'am, if it was subtraction.
We would put a minus sign here. Here, we would put a minus sign.
And ma'am, how would and ma'am, what would we do with the terms then?
What would we do with the sum terms? Arrangement same. This arrangement that I've done, same. Okay. But then solving would have been like in the subtraction form. Solving it
14
would have been,
minus 5.
yes.
7 minus 3.
Yes.
Okay,
Yes.
ma'am. Thank
Okay.
you.
Now we will solve it. Okay, minus always start from behind, from the last. Okay, grouping we start from the first, solving. Column method we start from the last, just like addition and subtraction, normal addition subtraction also, right? We started from the last, from the right side, right? So grouping also we always start from the back and start solving it from the last. So minus A as it is. Now I have plus minus. Okay, minus 14 plus 5. Okay, solve it. It's like minus plus is minus, so 9x. 9x is 14 minus 5, and 14 is like the bigger number, so we put the sign of the bigger number. Okay, then we have 7 minus 3. We have to plus them. Okay, we are like we subtract 7 minus 3, 4. Okay, and 7 is positive. 7 is positive, so 4 is gonna be positive. 4 will not become negative. Okay, understood the column method.
Yes, ma'am.
Okay, write it down and then yes.
Just one doubt.
Mhm.
If I had 7 minus y minus 14, ma'am, then how would I solve it? Can you just show me, ma'am?
7 minus y minus 14. And what would be the other term?
Ma'am, 5x minus a minus 3.
5x minus a minus 3. Okay, so you can like do it by grouping. You can group 7, 14 and 3 together.
Ma'am, so this is not possible by column, right?
This is gonna get very confusing by column. Okay, this is gonna get like very confusing by column. Okay, so you can like do it with grouping. When you think that like the terms you can see, okay, it's like a lot of like mixed terms are there together. You can just choose grouping. Okay.
Yeah.
And like when you can see that very like simple arranged terms are there, two terms of x, two terms of a, two normal numbers, very like arranged uniform terms you have, you can do grouping. It's up to you. Sorry, column. It's up to you. Okay. Then also similarly in ratio proportion chapter, you can use the like equation method, making the proportion equation and then doing, or you can use the unitary method also. Okay. In the like instead of proportion, you can do unitary anytime. Okay. Any day you can choose unitary over proportion. Okay. Like I'm still like I tried out some questions, but it was like different in every question. The x, like how where to put the x was different in every question. So like I'll try to work on a trick to teach you a trick to like arrange it and find it out. Okay. So that you cannot, you don't have to like do check the placement and then do again and again. Okay, you can just I'll try to come up with a trick with which you can easily do the like ratio equation. But until then, I'm like y'all can use the unitary method any day. Okay, easier and no confusion is there in unitary. So unitary you can do easily. Okay. And proportion also, like you'll get the answer, but you have to set up the correct equation. You have to set up the like x in the correct position. Only then like you'll be able to get the answer of like x in the proportion. Okay. Okay. Now we'll just see the distributive property. Okay, I'm clearing the screen. We're gonna see the distributive property. Abraham distributive law or distributive property is very easy. I'll show you. Joshua, you can like, if you're writing it down, you can write it down later. Okay, once I've explained it, then you can write. Anna and Joshua. Okay.
ma'am.
Yes. Like when I'm explaining, I want you to like stop writing and look on the screen and focus. Once like I'm done explaining, I give time for writing. Okay, that time you can write. Now, distributive property means that just like expanding the operation. For example, I have A, B plus C. Okay, distributive is what we expand the operation. Like A, I'm gonna multiply with B plus A, I'm gonna multiply with C. This is my distributive property. When I open it and expand it, I'm gonna get A into B plus A into C. Or you can write it like AB plus. This is my distributive property. Okay. Like when you're having a number outside the bracket and it's in multiplication, two numbers are in addition or subtraction inside the bracket, then you have to multiply the outside number with both the numbers that are inside the bracket. This is the distributive property. Okay. For example, I have A, B minus C. A, B minus C, then same thing we will do, but only the minus sign will come. Only the minus sign will come. What I will get? A into B minus A into C, or AB minus AC. Okay, AB minus AC. For example, I have 8, 4 plus 2. So what I will do? I will do 8 multiplied by 4 plus 8 multiplied by 2. And then I solve it. Okay, and then I solve it. Solve it, tell me. 8 fours are
Ma'am, 32.
I'm 32 and 60.
And the total?
I'm 48.
Yes, 48. Okay. So this is how you work out the distributive property. Okay, this is how we work out the distributive property. The number that is outside the bracket, we multiply it with all the numbers that are inside the bracket without changing the sign. Without changing the sign. Okay, if we had three digits, suppose I'm having a plus a b plus c minus d, a plus a, b plus c minus d, then my a will also be multiplied with d and it will become minus a into d. A into b plus a into c minus a into d. Okay, this is basically my distributive property. Understood?
Yes, ma'am.
Okay, Joshua, understood?
Yes, ma'am, I understood.
Yes, ma'am. Okay. Hmm. Write it down now. You can write it down. Do we have the math test on Wednesday or the science test on Wednesday? Science, right? I think so.
Ma'am, we have the science test on
Ma'am,
Wednesday.
we had the
Science.
science test on 16th and the maths test on 18th.
18.
Yes, ma'am.
Yes.
16th and then 18th. Science and then maths.
Yeah, 16 and 18. Science and maths. Joshua, if you want, you can attempt the test. Okay. If you want to like see how the test comes, okay. What about the test? If you want to, you can give it up to you. Okay. Uh, I think the fourth chapter, the fifth chapter,
Ma'am, the
math,
ma'am,
fifth chapter.
science. Science, the fifth chapter, and math, the fifth chapter. Ma'am,
Oh, yes, Abraham.
science is a little bit like it's biological, ma'am. Can we have it on Friday and have the maths on Wednesday?
Can we have the maths on Wednesday and science on Friday? Anna and Emma.
No, ma'am, I want the science first.
And Emma. Emma, like, how do you want it? Like, are you okay with the math first and science later?
Ma'am, I don't mind anything.
You don't mind.
I'm ready with for both. So
You're ready with both. Okay. Today is like Monday. Then you have like today, tomorrow. Algebra. Anna, how's your like preparation for the math test?
I just have few more things to prepare. That's why I want science first.
That's why you want science first. Okay. Then I guess Abraham, can you like prepare science? Okay, prepare science. Take today, take tomorrow. Then you have Wednesday is I'm gonna send the test Wednesday. Also, like I'm gonna send you diagrams to prepare. Okay, for the fifth chapter, I'm gonna put diagram PDF in the group. Okay. Um, just remind me if I have not posted it by like later evening today. I want one of you to put a reminder. Okay, send me a personal text and remind me that ma'am, science diagrams. Okay, sometimes I like get occupied and it slips my mind. So if I have not sent it by today evening, later evening today, just put a text. Okay. Now, fifth chapter. If like Joshua, you want, you can like attempt it. Algebra chapter is there. Okay. Or like if you want not to, then also it's okay for now. Okay. No problem with that.
Okay,
Then
ma'am.
yes, difficulty class I will take. I'm planning to keep a difficulty class for y'all for the like ratio and proportion chapter. Okay. Um, I will like let you know. I'll first have to check your homeworks. Okay. I've like not checked your homeworks yet. So I'll check your homeworks first and then I'm gonna like keep a difficulty class for y'all for ratio proportion. tomorrow we are going to start, like, we did time and work, right? I think we are going to start distance tomorrow. Okay, distance and time.
Ma'am, and speed.
Speed also, yes. Speed, distance, and time. Have you all written the distributive property? There's one question that I wanted to do with you all. Done writing, all of you? Shall I clear the screen?
Yes, ma'am.
Joshua, Hannah?
Yes, ma'am, I'm done.
Okay.
Yes, ma'am, done.
Okay. Okay. Now, okay, there are a couple questions that did I do the question where, like, Joseph and Reena complete the work in 12 and 24 days? No, I guess not. Okay, anyways, take a look at this question. Okay, very carefully. There are two people, Karan and Ahmed, who did a work, who can complete a work in, who can complete a work in 15 and 20 days. 15 and 20 days. Okay, like Karan can complete in 15 days and Ahmed can complete in 20 days. They both worked together for 6 days. They both worked together for 6 days. 6 days they worked. Okay. Then what happened? This Karan left the work. Okay. The Karan left the work and told Ahmed to do all the work alone. Okay. Now, what will Ahmed do alone? That is what you have to find out. Okay. How many days this Ahmed gonna take, the poor Ahmed who has to do all the work alone now? How many days will it take him to do the work alone? Okay. See, both we know that Karan can do in 15 days and let me write the name. Karan can do the work in 15 days and Ahmed can do the work in 20 days. Both together, both can do the work in 6 days. But this K left, Karan left. Okay. Now Ahmed, we have only Ahmed that is there. Okay. We have only Ahmed that is there. Now, the remaining work, how much time can he do it? The remaining work. Okay, so first what we'll find out. First we'll
Left after how many days? Like, how much of work did he do?
yes. How much days will he take to do the remaining work? How much time Ahmed will take to complete the work? Okay, to complete the remaining work. First we have to find out how much remaining work is there. Okay, and then we find out how many days it's gonna take Ahmed to complete that work. Okay, what are we gonna do is step one is we will find how much together they will do. Okay, how much they will do together. Then we will find out that what is their 6 days work. Okay, from that how much they'll complete in one day we'll find together, both together in one day how much they'll complete. Then we'll find out how much they did together in 6 days. When we have one day we can multiply it with 6 and find out 6 days, how much work they did together? Right, that we can find out. That's the second step. Third thing that we're going to do is we will calculate the remaining work. That is, how much work is remaining after the 6 day work is done. Okay, so that much will be your remaining work that Ahmed has to complete. Then we will calculate how many days it's gonna take him. Okay, if he completes the like full work in 20 days and we have the work that is remaining, we multiply it with 20 in the end to find out how much like days it's gonna take him to do the remaining work. This is like a little lengthy but easy. If you do it logically, it's gonna be easy. Okay, gonna feel simple. Now, shall I like do it today, like today, right now, or tomorrow? We have like a couple, 1 or 2 minutes. If you like, have to log out right now, just tell me. Yes.
Can we do tomorrow, ma'am? Because like only 1 minute is left for the class.
Yes, that's what I'm thinking. That's what I'm thinking, to do it like in detail, like because I gonna need detailed explaining to be done with you guys. So this question, I've told you the background of it, okay, but in detail, I'm going to solve it with you tomorrow. Okay, I'm going to solve this question with you tomorrow. What we are going to do if this Karan ran away, then how much poor Ahmed gotta do? Okay, we'll find it out in detail step by step tomorrow because this question is gonna take some time. Okay, also for the homework, I want you all to try out. For the homework, I want you all to try out exercise 7.5. 7.5. Okay, 7.5. I want you all to try out. There are some questions similar to these questions that we did about time and work. Okay, we have some time and work questions. Don't worry if you don't understand some questions. Not to worry if you don't understand some questions. Just do the questions that you are understanding and you are able to do. Okay, rest of the questions you can ask me. I can take them in the doubt class. Okay. I think we are going to do a doubt class after your test. After your test is done on Wednesday, if not Wednesday, Wednesday is science, right? After Wednesday, we are going to do the doubt class. Maybe Thursday or Friday. Thursday maybe. Friday you have math test, so no math class gonna be there. Okay. So like I'll see. Shall I keep a math class on Friday? Along with the test?
Ma'am, what about science?
Science? Science will be there regular. Science class will be there Friday. You have no classes on Wednesday because I have an exam on Wednesday. I have to go for an examination. So no science and maths on Wednesday, but science test is there on Wednesday and math test is there on Friday. Science class will be there on Friday, but math I'm thinking what to do with it. We'll see later. Okay, we'll see later. Right now, this question Karan and Ahmed, we'll talk about Karan and Ahmed tomorrow, and do 7.5 today. Try the questions as many as you can do. 7.5. I need your homeworks in the group. Okay. Before tomorrow's class, I need 7.5 questions in the group. Okay. Mark your difficulties. Mark your difficulties and keep also. So we are going to discuss that. Okay. Okay, then that's all for today. See you all tomorrow. Bye. Have a good day.
Bye, ma'am. Thank
Thank you,
you.
ma'am.
Bye.